Okay, so this is another example with a velocity graph. Hopefully this will help clarify everything together. So right here, this is the velocity graph given. This is broken down by little chunks. So this here is for the first 1 second of movement. So that's just this part of the graph. So you can see what's going on. The velocity here is negative. This is below the x-axis. So you could say that we are moving backwards because the velocity is negative, and the velocity right here is negative, but the velocity is changing. It's not constant. It's -2, -1, then 0. So since we have -2, -1, 0, you can say that the velocity itself is increasing, and you can tell that the line is getting higher. The line's increasing, so you can just see that the velocity itself is increasing. So speed, if it helps you, put next to the velocity positive numbers here, because remember, speed is pretty much the same thing as velocity. It's just always positive. So you could see if you read, the speed here is 2, then 1, then right here the speed is 0, that the speed is decreasing. So the speed can never be negative. This is not an option. Speed is always positive, but the speed itself is decreasing because the speed again is 2, then 1, then 0. And the acceleration, remember, is the slope. This is in feet per second squared. The slope is up 2 over 1 or 2. The slope is always 2 here, which is positive. So we have this. You could even say positive 2 feet per second squared. And the last part, the displacement, is the area from the graph to the x-axis. So that is this triangle area right here. So it's a 2 by 1, and half that is 1. So the object just moved 1 foot, and you could say backwards because our velocity is negative. We're moving in a backwards direction here. Okay, so at 1 second, our velocity is 0. So you could say we are stopped or we are at rest. Our velocity itself is 0. Speed is 0 with it. And the acceleration is still the slope of the line that it is on. So you could say the acceleration is positive, and it's still positive 2, because again, that's the slope. All right, now from 1 to 3 seconds. So this piece right here. So now we're moving forward because the velocity is positive. All of this is above the x-axis. The velocity is still increasing because the line is going up. The speed are all positive. Again, it can never be negative. The speed is increasing. So just read the speed numbers. Again, the speed is 0, then 1, then 2, then 3, then 4. So the speed's going up. And acceleration is the slope, which is positive. Still positive 2 because we're going up 2 over 1. The slope is always 2 on that line. So you can put over here positive 2 feet per second squared. And then the displacement, remember, that is the area from the graph down to the x-axis. So you just calculate this area right here. So it's 2 seconds. We could even just multiply this. It's 2 seconds times 1, 2, 3, 4 feet per second. And then it's a triangle, so half of that. So remember the 2 seconds and then the 4 feet per second. The seconds are going to cancel out. That's why you're going to be left with 4 feet. And that's how far the object moved in the next 2 seconds. So the displacement right here is 4 feet. 3 to 6. So this right here. So this is the graph that velocity is always 4. So we could say we are still moving forward because the velocity is always positive 4. The velocity is not changing, so it's a constant 4. The speed is a constant 4 with it, so it's positive. The speed is not decreasing or increasing. The speed is constant. The acceleration is the slope. That's the change of the velocity, which would be 0. since it's always 4. So you could say that the slope or acceleration is 0. The displacement, though, so it moved pretty far. So we go from 3 to 6. That's 1, 2, that's 3. You could say 3 seconds times 4 is the height of the rectangle, so 3 times 4, so that's 4 feet per second. So 3 times 4 is 12. Again, the seconds cancel out, you get 12 feet. So the object just moved 12 feet from 3 to 6. And you could look at the key for the rest of the way 6 through 10. Just keep in mind, if you want to break up the area, do it like this. This is the area of 2 here. Do a triangle here. So it's like a 2 and a 1. So the area for the first second from 6 to 7 is 3 feet. And then you have a triangle here, which is a 3 by 2. So that's 6. Half that is 3. So just calculate the areas. Always want to break shapes into triangles and rectangles if you can. Alright, so last problem on the summer packet, number 60. So just a little bit more help if you need it. If you look, this is a velocity graph for 10 seconds at time 0. The original position of the particle is at 3 feet, or you could say p of 0 equals 3, where this is, again, velocity graph over here. So A is asking you about a change in position, which just means displacement, and you're going to figure that out by getting the area of this whole shape. So remember to break this up into easy shapes if you can. So maybe cut it here so that you've got a little rectangle here, 1, 2, 3, 4 here. And this is a triangle, so you got 1, 2, 3, 4 by 2. 4 by 2 is 8. So again, this is 4. And that right there is a half. That's a 1 by 1. Half that is 1/2. So altogether, this would be 8.5 feet. So the particle moved 8.5 feet forward for the first 5 seconds. Part B, what is the particle's position? Well, you're taking the original 3 that it started with. It just moved 8.5 feet forward. So by the time it got to 5 seconds, then this little particle is at 11.5 feet. So that's what it's asking you to do there. Average acceleration means go get the slope from 0 to 5. So again, that's how acceleration is related to velocity. So at time 0, the velocity is 1. You could go like this if you want. The velocity at 0 is 1. The velocity at 5 is 0. So then if you do a down to y, down to x, so then you could go like this, 0 minus 1 over 5 minus 0. And then your average acceleration is -1/5 feet per second. So it's basically just going down 1 over 5. That's how you get your slope or your acceleration. Instantaneous acceleration is just the slope itself right at 5. So since it's linear, right here at 5, you just get any 2 points that you want and then go get the slope. So it would just be down 1 over 1, doesn't matter where you're at. The slope is always going to be a -1 anywhere on the line, and then feet per second squared. Moving backwards or forward, so this is just knowing velocity, positive or negative. Velocity is positive, all here. So forward, so 0 through 5 seconds, you're moving forward. Backwards, the velocity is negative, so that'd be 5 through 10 seconds. Remember, you could also go like this. 5 is less than t is less than 10 if you prefer. All right, at rest means stopped. So you could say at 5 seconds, the velocity is 0. 10 seconds, the velocity is 0. Changing direction means the velocity changes its sign because you're moving from forward to backwards. So again, right at 5 seconds, that's when changing direction happens. You're moving forward and then you're moving backwards. Okay, G, what is the particle's change in position from 0 through 10? So I'll let you try that one, look at the key, but you've already figured out part of it, like all this area is 8.5 feet. then you have to go calculate this, and this will be a negative answer, and you're going to add those two up together. HI about speed. So speed, remember, is the velocity, only it can't be negative. So that's why this is a velocity of -1, but the speed is 1. Right here, the speed is 2. So if you're looking at 3 seconds, you just go to 3, you go up to here, the speed and velocity would both be 2. That would be it, feet per second. So at 6, you go to here, the velocity is -1, but the speed is +1 feet per second. So speed increasing would be here, and it would also be here. So again, just read the speeds 1, 2, 3. So speed's increasing from 0 through 2 seconds, and then from 5 to 7, because the speed is 0, then 1, then 2. So you want to add 5 through 7 seconds there. Speed's decreasing 2 through 5. And then here, starting at 7, the speed is 2. Speed is getting smaller, eventually 0 right here. So speed is decreasing starting at 7 through 10. And if you tried G, let you try that, it should come out to be 3.5 feet. You could see if you did that right.